This presentation will briefly outline a way to accelerate the global energy transition by encouraging many organizations around the world to use AI to develop and deploy decarbonization projects faster. In addition, I will highlight the huge potential of hydrogen extracted from the Earth, which I will refer to as geologic hydrogen. To begin, I will highlight a key current climate trend and a UN statement on the need for substantial climate action. Then, I will outline how AI can help develop and implement many climate action projects, including ones with renewable energy and/or geologic hydrogen. As shown in the graph on the left, carbon dioxide levels in the atmosphere appear to be rising at increasing rate. The graph on the right is showing the amount of CO2 emissions in billions of tons per year estimated by the Global Carbon Project. The latest year shown in this graph is indicating that approximately 37.4 billion tons of CO2 were emitted globally in 2024. Since the amount of CO2 emissions are continuing to increase, it appears that total energy demand is rising faster than renewable energy generation. As a result, much greater climate action is required, which is summed up by the UN Secretary-General, Antonio Guterres, who said, "Our world needs climate action on all fronts, everything, everywhere, all at once." Fortunately, AI is improving very quickly and now has a wide range of capabilities that can be utilized by organizations around the world to help accelerate climate action. We will highlight some of the key capabilities of AI in this set of slides. AI can help educate organizations around the world about the need for sufficient climate action and what can be done about it. For example, AI can explain current climate trends and tipping points. Next, it can provide an overview of significant technologies that can be scaled up to implement the energy transition. Then it can generate overview reports about selected topics with references. Shown here is a link to an example report by Google's Gemini Deep Research about how AI can help accelerate the global energy transition and unlock new low-carbon frontiers. AI has a wide range of capabilities and can be utilized by millions of organizations around the world to help develop and implement many climate action projects. Given below are some examples of how AI can help an organization develop and implement a project. First, identify potential profitable projects that can produce low-carbon energy, renewable fuels, and/or increase energy efficiency. Second, identify appropriate technology suppliers and their contact information. Next, identify potential off-takers and their contact information for a product or products produced by a project, such as green methanol. Next, identify relevant and available financial incentives that could help support a selected project. Next, provide online links to references that enable organizations to verify the information generated by AI. Lastly, AI can help estimate the profitability and expected cash flow of a proposed project. Shown here is an example of an integration of wind turbines, solar panels, and energy storage. AI can help an organization do a deep dive into a selected topic and/or help facilitate the integration of selected technologies. For example, Google's Gemini Deep Research can produce detailed, reference-linked reports. Shown here is a link to an example report by Gemini Deep Research, Artificial Intelligence, a strategic accelerator for global decarbonization infrastructure deployment. In addition, Gemini can assist in integrating technologies for climate action projects, such as facilities that combine renewable energy and energy storage with geologic hydrogen to produce reliable power for the electricity grid. Naturally occurring hydrogen can be extracted directly from the Earth and has been given multiple names including geologic, natural, white and gold hydrogen. As well, it also can be generated in certain rock formations. When it is generated this way, this type of geologic hydrogen is referred to as orange hydrogen. The U.S. Geological Survey has completed a major study and has estimated that the Earth holds over 5 trillion tons of this type of naturally occurring hydrogen in underground pockets, which is an extremely large amount. They also indicated that a few % recovery of this amount would still supply all the projected demand for hundreds of years. There is already a commercial site producing geologic hydrogen near Borakabugu, Mali. It started production in 2012. Additionally, 46 million tons of geologic hydrogen has been estimated to be found in the Lorraine Basin in France. As a result, geologists are predicting a natural hydrogen gold rush. Recently, a group of scientists published an article indicating that there's enough natural hydrogen in the Earth's crust to help power the green energy transition. Shown here is an infographic by the U.S. Geological Survey that outlines multiple ways how hydrogen is produced in the Earth. The main way it is produced is by warm or hot water reacting with the iron in the rock. Since there is warm or hot water and iron in the rock in many areas of the Earth's crust, it can be assumed that hydrogen is being produced in these areas around the world. To accelerate the process of finding geologic hydrogen, artificial intelligence or AI services can be used to review available data relating to land resources around the world, including data from satellites, to determine an initial set of areas that could then be reviewed further by experts to determine the best locations for exploration. When doing so, these services can analyze available data for many parameters including the best geological formations, proximity to a potential electrical grid connection, proximity to markets including population centers, access to adequate roads to transport equipment, supplies and hydrogen, as well as data available from technical surveys including gravity, magnetic, seismic and geochemistry. Shown here is a geological cross-section of northern France, illustrating the location of potential hydrogen resources in the Lorraine Carboniferous Basin. These geological hydrogen resources have been estimated at 34 million tons between 0 and 3,000 meters in depth. A significant new tool has been developed to facilitate the identification of geological hydrogen resources. For example, the discovery of a potential resource of 34 million tons of geological hydrogen in France was made possible thanks to this tool, which analyzes dissolved gases in aquifers in situ. This tool could be used worldwide to identify many other important sources of geological hydrogen. Called CIS-MOG and was patented in Europe in July 2024, it was developed by Seoul experts in partnership with researchers from the Geo-Resources Lab, from the University of Lorraine and CNRS. A $15 million research project, led by Française de l'Énergie or FDE called Rigolor 2, is currently underway to validate this resource and develop a low-cost method for extracting this hydrogen. For more information on the discovery of hydrogen resources in the Lorraine Basin and on the researchers' future projects, see the slideshow, Hydrogen Dissolved in the Lorraine Coal Basin. To help accelerate the exploration and utilization of geologic hydrogen, we recommend that an AI Center of Excellence be established. Shown here are some key activities that could be implemented by this center. First, process available data to identify the best areas to explore for geologic hydrogen around the world. Next, help organizations identify how best to utilize this hydrogen, such as combining it with renewable energy and producing renewable fuels. Finally, create awareness of how organizations can use AI to develop and implement sustainable projects. In conclusion, based on rising global CO2 levels, the total energy demand appears to be rising faster than renewable energy generation, which is creating an urgent need to accelerate the generation of clean energy. AI has a wide range of capabilities and can be utilized by millions of organizations around the world to help develop and implement climate action projects on a large scale. The U.S. Geological Survey has estimated that there is over 5 trillion tons of geologic hydrogen trapped in underground pockets. Given this estimated abundance and that AI can accelerate its exploration and utilization, geologic hydrogen could play a vital role in the global energy transition. In addition, AI can accelerate the energy transition by helping organizations around the world develop and deploy more climate action projects faster. We recommend that a global media campaign be implemented to create awareness about how AI can be utilized by millions of organizations around the world to help develop and implement many climate action projects. To accelerate the process of finding geologic hydrogen, AI services should be used to review available relevant data around the world to determine the best locations for exploration. An AI Center of Excellence for Geologic Hydrogen should be established to help accelerate the exploration and utilization of geologic hydrogen and its integration with renewable energy. As the UN Secretary-General has said, our world should take climate action on all fronts, everything, everywhere, all at once. We believe AI can help answer this call by helping to accelerate the low-carbon energy transition. Thank you for taking the time to view this video. If you are interested in more detailed information about these opportunities, including links to websites of organizations mentioned in this video, please visit climatesan.org/ATAI.